Okay, like I said before you left today, the lesson today is Unit 4, Lesson 3, and it's very similar to what we've been doing. We've been talking about the inverse operation between addition and subtraction, and today we're going to talk about the inverse operations with multiplication and division. They're very much like multiplication and addition and subtraction are opposites, multiplication and division. They undo each other. A factor pair for a number is a pair of whole numbers whose product is that number. So you have to have two factors to have a multiplication problem. You have to have two factors multiplied together to get a product. The product is an answer to a multiplication problem. So if you're looking at this diagram over here by my little X thingy, my green box over here, which numbers in this rectangle model are the factors? Well, that's pretty easy. It's a 7 and the 9. Where are the factors located? And that's also pretty easy. They're located on the sides. So this 7 is a factor and 9 is a factor. So which number would be the product? The product, well, there's only one number left, is 63, and it's located inside the rectangle. So it's pretty easy to see, like we were doing the number up here, like this is 10, 8, and 2. It's kind of the similar piece where the sum is this top number and the product is this number. So moving into that rectangle model can help us find all the related multiplication and division equations, just like we were doing the addition and subtraction problems. These are the same things. So if we're writing 8 related multiplication and division equations for the rectangle model here for number 3, you're looking at what just happened. Well, that was freaky. I'm not sure what happened there. Okay. You're looking at 96 is your product. 96 is your product. And then I would do equals 96. Equals 96. Each one of these is going to have a 96 in it. Equals 96. Equals 96. 96 is going to be divided by something. 96 divided by. 96 divided by. Now that I have 96 in each one of these, I'm not going to worry about that number anymore because I've taken care of it. Now I can do 8 times 12 and 12 times 8. I can do 8 times 12 and 12 times 8. And then I can do 12, 8. 8, 12. 96 divided by 8. 96 divided by 12. You see where I'm going with that? So it's just like adding and subtracting, only it's multiplying and dividing. So if you need to press pause right now, you might want to go over to the form because the first 2 questions have a lot to do with what I just did on this page. You can press pause at this point and complete that if you need to, and then click back and forth. We're going to move on to page 144. Okay, so what I noticed today when we were talking about the situation equations and the solution equations, you aren't really sure what to do with that situation equation. Basically, and bottom line, the situation equation is always going to have a variable in it because that's what you're trying to figure out. It's a way to record the information that the word problem gives you. So we're going to read through here at the top of 144 this question, and it's broken down the steps. So we're going to read the problem and answer the questions. So Brenda planted 234 trees on her farm. The farm has 9 rows of trees. How many trees are in each row? So we need to think of this as these are the rows, or these are the trees. These are the rows. Okay? Think of back to like 3rd grade when you were talking about your arrays. Okay? The number of trees on the farm is shown. So how many trees were on her farm? That's the total number, right? 234. The number of rows of trees is known. How many rows of trees are there? 9. The number of trees in each row is that unknown piece. That's what we need to find out. Use the letter N to represent the number of trees in each row. Write a situation equation to solve the problem. So how am I going to solve this problem? 9n equals 234. And you can use whatever variable you want. You can use, if it makes sense to you, then you can. Okay, so somebody walked in and I got distracted. So what you need to do is, here's your situation equation. This right here is going to tell you how to solve our problem. Well, the solution equation is how are you going to solve it? So I always start my solution equation with my variables. So n is going to equal 234 divided by 9, because it would be the opposite of what you are doing in your situation. So the answer is n equals 26 trees. So let's look at 5, 6, and 7. We're going to do the same steps as we did above. Evan is starting a cycling program. He will ride 315 miles each month for the next 6 months. How many miles does he plan to ride in all? Well, what do I want to find out? How many miles does he plan to ride in all? So miles equals 315 miles times 6 months. Well, in this case, our situation equation is almost exactly like our solution equation because that's the way it unfolded. So here you're going to multiply 315 times 6 and you'll get the miles in all. I'll let you do that multiplication because you need to practice it. So press pause and do that. Suki has 152 stickers to place in a sticker album. How many pages will Suki fill with stickers if each page in the album holds 8 stickers? So Suki is starting off with 152 stickers. How many pages will she fill if the stickers on each page in the album holds 8 stickers? So I'm going to divide this 152 by an unknown amount of pages because I know that each page is going to have 8 stickers. Another way to write this could be pages times 8 equals 152. Are you seeing how it could be either one of those? Either one of those equations could be the situation equation. So I am going to, for my solution equation, I'm going to have to divide 152 by 8. to find out how many pages I will need. The last one, and I'm going to let you figure that out, friends. So this answer is going to be each page in the album. So this answer is going to be pages. I'm going to do number 7 over here for you. Al bought a wall pattern with 27 rows of 28 squares. 27 rows of 28 squares. How many squares are in the wall pattern? S for squares. There's my situation equation. This is new verbiage, I know. It's basically what problem are you going to do to get the answer? So now to solve it, I'm going to multiply 27 times 28 to get how many squares. And I'm going to let you multiply that out, and we will correct it first thing in the morning to see how you do. I gave you the equations. Here's your situation equation for number 5. Here's your situation equation for number 6. And here's your situation equation for number 7. Hopefully you understand or are starting to get it. We'll do a couple more examples tomorrow in class in smaller groups. Make sure to fill out the form and submit it so I can see that you have joined in on this mathematical journey. Sorry this is late. See you tomorrow.